Most welcome student. This is Stoichiometry chemistry faculty. Now student, we are coming the next part of the stoichiometry, and this today topic is this is a law of chemical combinations. Now you must be remember that as if you compare with the mole concept is very important for physical chemistry because you know that what is the mean of the mole. It means how two element molecules and ions are react, and what is the constant values of the reacting the different type of elements compounds. Clear? So this is a mole. Now similarly, the very important thing is law of chemical combinations. It means participation of different element and compound in the reaction. There are only four concept methods, and these are following. Now we are coming the first one. First one is this is a law of conservation of mass. This is actually given by Lavoisier, and this is law of conservation of mass. Is explain that mass is neither created nor be destroyed, but change one form to another form. Clear? Now this is actually explained by with the help of the experiment. It means experiment verification is given by Ladold. Ladold experiment explained that this is a H type of tube. In a first one has a compound, this is a, and the second one has a compound is B. A and B is a react, then form a C and D. So before reaction, weight of compound is A plus B, and instrument weight is W1, and after reaction C plus D whatever is formed, so the weight of C plus D and instrument is coming is W2. So before and after the reaction, weight is never changed, weight is always constant. It means it proves the law of conservation of mass. But you must be remember that there are some limitations, and the limitations are this is a delta E barabar delta M C square, which is this is we know that this is a Einstein equation. Delta M is this is a M is a mass defect, and mass defect is actually occur in a nuclear reaction. It means if the compound are reacting in a nuclear reaction, there is some mass is a loss in the form of energy. Clear? And this is a defect in a mass is delta M, and that way is a possible in a nuclear reaction. It means a nuclear reaction is not follow the law of conservation of mass. Clear? You must be remember that. Now after that we are coming the numerical related to this one. Now question is what mass of the sodium chloride would be decomposed by 9.8 gram of sulfuric acid and 12 gram of sodium bisulfite and 2.75 of HCl was produced in a reaction, assuming that it follow the law of conservation of mass. Now question is saying that if the NaCl is react with H2SO4, then form NaHSO4 plus HCl. Suppose here we take a weight of NaCl is X and weight of H2SO4 is actually given as a 9.8 gram, and formation of sodium bisulfite is 12 gram and HCl is 2.75 gram. So that X is coming is 4.95 gram. It means it follow the, if we put the value of X over here, so both weight is coming is equal, and so that we know that it proves the law of conservation of mass. Clear student? Now after that we are coming the second law. Now law of constant proportion, this is the second law. You must be remember that it is given by Proust. Law of constant proportion is explained that if any compound is formed by its element, if the participation of the element is always constant, it never be changed if this compound is extracted by any methods. Clear? Now here we take an example, then you know very well with the help of example. Now for example we take an example of H2O. H2O is formed by H and O. If this H2O is extracted from a pond, river, sea, anywhere is there, so the participation of hydrogen and oxygen is always constant, means 2:16, means 1:8. It is always constant. Clear? So this is explained that law of constant proportion. Now here we take the second one. This is the CO2. CO2, carbon and oxygen is ratio is always same, means 3:8, means CaCO3 if the heating then also produce a carbon dioxide, and simply carbon dioxide which is present in atmosphere, then the ratio of carbon and oxygen is always constant. This is always 3:8. If mean carbon dioxide is extracted in any way, any methods from anywhere, then the ratio of the carbon and oxygen ratio is always exists 3:8. Clear? Now this is only not for only carbon dioxide. It will be occur for any type of the compounds. Here we take two things. First one is a water and the second one is a carbon dioxide. Now there is a one limitation. It means not followed by the that one conditions. Means these four conditions are not followed. Now here we are talking about a non-stoichiometric like Fe 0.98 O1. Fe 0.98 and O1. This is never follow this law. Clear? This is never follow this law because it don't have a constant ratio between elements of iron and oxygen. Means iron or oxygen की भी constant ratio नहीं रहेगा. This is actually defect. It may be 0.98, it may be 0.93, it may be 0.94, anywhere is there. Clear? So this law is never applicable for a non-stoichiometric compound. Clear, student? So here we are actually discussing two law. Two law are also remaining, and as well as the Gay-Lussac law. This is the fifth one. We are talking about in the next video, and as well as a numerical to that one. We're discussing in the next video. You maybe see properly and stay tuned with us and within our channel. Now thank you and thanks a lot.